Here is how to build a full video analytics application using one line of code. I'm talking about a full application that can grab a video and perform all kind of AI analytics using AI models and more. Let me show you the deep learning streamer in a few minutes. Our application is a full pipeline. The input could be a video from a camera or a file or an RTSP feed. The video has to be decoded or uncompressed in order to process it. Many times we need to perform all kinds of format conversions and image processing to fit it to the AI model input sizes. Then comes the inference, maybe by one model, maybe by several of them. And then we need to post-process the results. The output of the AI model might just be coordinates for bounding boxes, and we have to actually draw them on the image. And then we need to present it to screen, encode or compress it back to video format for storage or for streaming. Many operations, many challenges. You can run all of these operations on a CPU, but that will not give you the performance and you won't be fully utilizing your system. Hardware acceleration is essential. There are many options to run each of the pipe stages on a dedicated on-chip accelerator. The Intel integrated GPU, for example, has a silicon block, a dedicated fixed function to accelerate decode. It can decode many more video channels in parallel with much higher efficiency than the CPU. Computer vision tasks are sometimes faster on GPU, but sometimes on a CPU. Inference can run on CPU, but the integrated GPU will probably give you better performance, and the NPU, the neural processing unit, will execute it with lower power and higher efficiency. Post-processing is again a CPU or a GPU game, and encode has another dedicated function in the GPU that can accelerate it. Few issues with this flow. Running each of these pipe stages on a different device, CPU, GPU, or NPU, means transferring the data, and this is video, so huge amount of data, back and forth between the devices using caches or DDR might not be very efficient. In addition, writing code for the GPU, CPU, or NPU is very different. Each of these devices has a different software stack on top of it, different programming model, and so on. Well, DLStreamer makes it all look very easy. GStreamer is a framework for creating streaming video applications. It is free and open source and widely used. Look for it online. GStreamer can take elements, pipeline them to each other, and construct a full workload. GStreamer elements could be, for example, open a file for video reading, decode the video, convert the format, and so on. To this pool of GStreamer elements, the DLStreamer adds analytic elements. Look for the DLStreamer or follow the link below. You can find here the developer's guide. Let's check the elements. You can see here inference plugins, elements. They all begin with GVA for GStreamer Video Analytics. This one can perform detection. This one can run classification, general inference, and many other operations. A typical DLStreamer pipeline might look like that. This is really one line that describes the full pipeline. The source of this pipeline is a video file. The exclamation marks indicate a new pipe stage, and the next stage is to decode the video and then convert the format so it will match the inference input format. And now we're running inference. The model is face detection, and we can add here all the required parameters. And now we want to draw the detection results on the original image. So the GVA watermark element will do that and display it to the screen. One line, GStreamer elements, plus GVA elements, and you have a video analytics full application. In this video, we'll install and run a Hello World pipeline. I will overview how to run the samples and dive into interesting elements and other useful operations in the next videos. The OpenEdge platform has many AI suites per industry and usage, a very useful Edge AI libraries. Let's look at the deep learning streamer. Here it is. Look for the install guide. I'll leave you the link below. Make sure you have a supported system and just follow the steps to download the package, install the prerequisites. It could take a minute, sudo update, and install the DL streamer. Now, in order to run anything, I will need to download few AI models. So here, I downloaded just a YOLO model. It will be automatically quantized to int8, as you can see right here, and I'm all set for our first DL streamer demo. If you're not running this right after the installation, make sure you have all the environment variables set and directing to your models and other preferences. The Hello World demo is really just one line of code. You can see it right here. We are streaming a video from the internet. This is a URL. Then we decode it, do some processing, GVA detect, and this is a YOLO model. It will run on the GPU. GVA watermark will present the results on the original video. We have here an FPS counter, and so on. I will explain each of these elements in my next videos. And now, let's run it. Hello DL streamer. You can see that the video is being streamed and analyzed. You can see the watermark on the video with the bounding boxes, and you can see the report. It executes this pipeline almost 100 times per second, 100 FPS. Deep Learning Streamer, a full video analytics application using one line of code. I love it. I hope you'll find it useful. Thank you. Subscribe.